Thank you for joining, everyone, and welcome to today's session. In case you're in the wrong room, we're doing CON308 about reducing your operational and infrastructure costs with ECS. My name is Vibhav. I'm a senior product manager with Amazon ECS. I've been with ECS for about 2.5 years now. Over the course of this time, I've had an opportunity to interact with a number of customers and help them in a number of different ways, and also impact the product right across the data plane, the control plane, scheduler, deployments, whatnot. I will give a quick heads up. We have a lot of content to share with you all today, so we might not have a ton of time left at the end for Q&A, but I promise to stick around. I'm also around till Friday here at re:Invent, so if there's any questions that you would like to talk about afterwards, please do feel free to reach out. So before we go ahead and look at the agenda for today's session, I wanted to take an opportunity to set a quick preamble for this session. It's adapted from the AWS well-architected framework, but in principle, my pitch here to you today is that I want to share all of the best practices that I've learned speaking to customers and our principal engineering team over the past 2.5 years, and share best practices which, when utilized well, can help you save up to 30% cost, or even in some cases 73% cost, which we've seen our customers do. So quickly walking through the agenda for today. So I'll start with a quick overview of Amazon ECS for those who might not be super familiar or not already using ECS. After that, I'll spend time on how you can, I'll spend a bunch of time talking about how you can optimize your workloads with ECS. I'll be talking across 3 subsections. And finally, I'll be handing it over to Francis, one of the customers I've worked very closely with over the past 2.5 years, who will be sharing his journey of how they have built their platform on ECS and how they've been able to run their organization in a super efficient manner. Quick show of hands before I move on. How many in the audience are using ECS today? Pretty cool, so about 70% folks. So for those in the audience who aren't using ECS today already, ECS is a fully managed container orchestration solution. ECS was introduced about 8 years ago at re:Invent itself. Since then, we've added a number of capabilities over time. When it started, you could use ECS to run your containerized applications on EC2. Later in 2018, we introduced Fargate, which is a serverless compute engine for running containers. And most recently, in 2021, we launched ECS Anywhere, which allows you to run containers on your own compute running in your own data centers or at the edge. There's 2 key statistics that I'd love to double-click on here. First, 2.25 billion tasks every week. So that's the scale at which customers rely on ECS. So every week, we see customers launch over 2.25 billion tasks on ECS. And this is distributed across hundreds of thousands of customers. The second big stat I would like to focus on here is that 65% of all new AWS containers customers choose ECS as their first platform for running containers. Many of these customers, in fact, might be new to AWS itself and often see ECS as their first intro to the cloud. Before we move on, a quick intro to Fargate for those who might not already be familiar with Fargate. So Fargate is a serverless compute engine for containers. When you run containers on Fargate, you don't need to think about managing the underlying instance. You don't need to think about the underlying host operating system. You don't need to think about patching. You don't need to think about things like observability or agents to gather that information, local storage. All of that is taken care of. The way we think about ECS is that ECS's value proposition closely ties with AWS's value proposition as a whole. And that really boils down into 2 simple things. By being performant at scale and providing availability and reliability and giving you a simple interface to manage and run applications and containers, we can help you unlock cost savings, better availability, and help you get to production faster, help you get features out more quickly so that you can innovate faster for your customers in this day and age. And that's why increasingly we think of ECS as your platform team. Our goal is to provide you opinionated and managed experiences with the right level of flexibility, of course, but with the two key goals as I identified earlier: improving time to production and reducing operation overhead so that you can focus on what really matters and your developers can focus on what really matters. So with the intro out of the way, I'd like to spend a couple of minutes talking about how I'll be going through the rest of the session. So I'll be talking through three key principles here. First, operating less. Why? Because when you operate less, you have more time to do other things that matter more. If you spend less time patching hosts, managing software that does orchestration, if you spend less time managing armies, you get more time to focus on innovating, to focus on improving all the other things that move the needle for your business. Secondly, utilizing more efficiently. So the way I think about it is the best way to save costs is to use your compute more efficiently. So we'll be doing a deep dive on how you can run your containers efficiently with ECS and how that can unlock cost savings for you. Finally, we'll be talking through some infrastructure choices on AWS that you can make to reduce your TCO quite substantially. So, and when you do all of this, it can unlock significant cost savings for you. So let's start by the first pillar that I talked through, operating less. So customers want to focus on innovation, and the goal of containers is to facilitate that innovation. However, it does take time to get through towards that end. You need to build out your application and then encode it into containers, and finally deploy them into production. But once that's done, it's not done. You need to continue to manage your application. You need to maintain hosts, patch hosts. You need to observe, make continuous improvements. Now, if you use any other container orchestration solution, you not only have to manage all of this, you also have to manage the orchestrator itself because it's not a fully managed solution. However, when you're using Amazon ECS and Fargate, you can focus purely on your application, which is your code, and focus and unlock innovation that way. Before we go into the how, quick note on how we think on why we think so. So increasingly, we see ECS as a serverless container orchestrator. Now, what that means is ECS, you don't need to think about a control plane in ECS. When you create a cluster in ECS, it's not a physical entity that lives in your AWS account. It's purely a logical namespace that resides in your account, which you can use for distributing applications in the right manner that works well for your organization. There's no charge for the compute for the control plane, and the control plane is provided as a fully managed service by ECS, and which runs at immense scale, as we already showed. And secondly, Fargate is a serverless compute orchestration a serverless compute engine for containers, as I said earlier. You don't need to think about hosts. You don't need to manage capacity. You don't need to think about armies, or operating system, agent, none of that. So let's go back and take a closer look at how ECS manages all of this. So first, let's start at the build stage. So while there are a number of other different ways that you can deploy to ECS, including the API, CLI, you could use CloudFormation, console, whatnot. Increasingly, we think about higher level interfaces which customers can use to develop on ECS. And they take a number of different shapes. So the first being ECS blueprints. So these are Terraform-based blueprints that are available as an open source project on GitHub and maintained by AWS, which allow you to get started really quickly with your first deployments in case you're already using Terraform. And it's not only a getting started solution. It's something that allows you to get started with best practices and continuously evolve that configuration over time so that you're architecting with the best practices from the get-go. CDK extensions. Similar to ECS, similar to blueprints for Terraform, CDK extensions provide higher level construct with CDK, CDK being an interface for infrastructure as code, which allows you to provision infrastructure in the programming language of your choice. Finally, Copilot CLI. Copilot is an opinionated CLI which allows you to run applications at higher order constructs so that you don't need to think about things like creating a build pipeline, looking at infrastructure, looking at the application spec. It's almost as simple as saying, here is my container, AWS, please run it for me. We'll do a closer look at Copilot CLI in a couple of minutes. I'd like to spend a couple of minutes here. So traditionally, when you deploy an application on EC2, there's a shared responsibility model that you're signing up for. There's some things that you manage, whereas other things that AWS manages. When you run a traditional EC2 machine, typically AWS manages the virtual machine itself, as well as the physical server. However, everything that's over that layer, including your application, the operating system it's running on, the runtime, any storage monitoring, logging plugins that you need deployed on your hosts, all of those need to be managed by you. Now, over time, that can add significant overhead. This was the reason why we introduced ECS EC2 back in 2014, to take on some of that responsibility away from you so that you can focus more on the application layer. So when you use ECS with EC2, you can use ECS optimized armies, which provide a managed host, which provide a super lightweight Amazon machine image, which you can use to run your hosts, which includes the container runtime, storage and logging plugins, the operating system. However, this is still in your account, and you still need to manage everything associated with patching and whatnot. However, with Fargate, all of that is abstracted entirely by ECS. You don't interact or see the host operating system. You don't see the container runtime. You can choose to not worry about monitoring or logging plugins. All of that comes fully baked so that you can focus purely on your application. And that is why we're seeing customers increasingly choose Fargate as their first way to deploy containers on ECS or in AWS in general. Now, moving on, another key topic that I want to cover on is the observability part. ECS brings observability out of the box. So in 2019, we launched CloudWatch Container Insights, which allows you to simply say, hey, ECS, I want observability baked in for my cluster, and ECS automatically provides application metrics for all applications running on your cluster at the granularity that you want. For logging, ECS provides Firelines for ECS, which allows you to send your logs to many destinations depending upon what your logging platform is. However, observability isn't just about observing metrics and logs. Observability is also about observing costs, and this can be super, super important when you're trying to cut down costs given the current macroeconomic environment. However, as those of you already run containers might know, monitoring costs for containers is hard. If you're launching containers which last for only a few minutes, which are sharing resources across an EC2 host, which is shared by multiple different containers, it can be really hard to keep track of how much compute is being utilized by which application and allocating that cost at an application level. This is a really hard problem. However, when you use ECS with Fargate, ECS provides you container-level cost visibility out of the book. So when you run your application with ECS, you can see how much you're paying per application instead of seeing how much you're paying per box. What this means is that by using tags you can get to really granular data, really granular cost data for your application, which you would not be able to do otherwise, even in a shared multi-tenant environment. Before we end this section, I did want to briefly double-click on AWS Copilot, especially for those of you who might be new, who are new to ECS. So Copilot is built with well-architected principles in mind. So what that means is when you launch your first application on ECS with Copilot, you're already well-architected from the outset. So your first application itself uses load balancers efficiently. It uses health checks. It has observability, all of that built in. What's more, you can build things like Copilot also makes it easy for you to set up deployment pipelines, which make it really fast and easy for your development teams to push out code. Also, Copilot makes it easier for you to troubleshoot and operate, especially for developers, especially for environments where you have developers running and managing the entire stack. But taking a step back before we move to the next section, when we think about all of the things that I spoke about combined, it creates the amount of time saving that it creates for you to not think about managing the control plane, the data plane, hosts, patching. All of that time can be used for driving innovation, for improving your release velocity, for spending time on other things that you can use to cut down your costs. With that said, let's move on to the next pillar, utilizing more. So I'm sure, I hope most of you are familiar with this image. This is the image that always pops up in my mind when I think about running containers efficiently. Just like in Tetris, the goal is to fill up lines perfectly and increase your score. When you run containers efficiently and utilize your compute efficiently, you save costs. And that's why, as I said, the best way to optimize your costs is to improve efficiency of utilization of your compute. Before we move on, for those of you who aren't super familiar with ECS, I want to take a quick moment to talk through some ECS terminology here. So not a lot, just 3 quick terms. First, cluster. A cluster in ECS is nothing more than a namespace. It's not a physical entity that resides in your account. It's fully managed by ECS. You can create as many clusters as you want. An ECS task. Task is the smallest unit of compute in ECS. Task is a group of 1 to 10 containers, which typically might constitute one single unit of an application or a microservice. And finally, services. An ECS service typically represents a group of running tasks which combine to form a microservice. The service construct in ECS provides inbuilt resiliency. What that means is if a task crashes, if a task in a service crashes, ECS ensures that it will bring it back up so that your application remains highly available. So with that out of the way, I'll take a step back to talk about the 3 key dimensions that you can think about to improve compute utilization. The first one being size of the task. So when you run a container on ECS, you need to configure how much compute you need for your container. So you might say I want 1 vCPU and 4 gigabytes of memory. But depending upon how you utilize that or how much your application needs, there might be an opportunity to cut costs. Secondly, number of tasks in a service. So how much traffic your application sees over the course of a day can vary a lot. You can use this to make sure that your applications are always right-sized. And finally, compute capacity in the cluster. This represents the synthesis of everything else. So if you have, say, n instances running in your account, you want to ensure that those n are being utilized to the right extent possible. And by doing that, you can obviously save costs. So let's start by looking at the task level. So let's look at this example scenario. So if you look at this application, it's pretty clear that it's becoming CPU bound, whereas there's a lot of, it isn't using more than 50% memory at any point of time. So in this scenario, you could easily reduce the amount of memory that you've reserved for this container, and at the same time increase the amount of compute you have reserved, and reduce. And by doing that, you could likely save some cost. Right-sizing tasks is important. You need to look at historical metrics over a reasonable period of time in order to make sure that you're right-sizing your task correctly. And it's OK to not size your task correctly on day one. This is something you can correct over the course of time. In order to do right-sizing well, you can use container insights that I spoke about earlier, which allow you to monitor historical compute utilization data for each task or application, and you can look at the average as well as the peak utilization to make sure that you've sized your tasks correctly. With that said, let's move on to the next big pillar: number of tasks in your service. So the amount of traffic that your application serves can vary a lot. So let's say this application needed 10 tasks at peak. At different times in the day, this application might need 6, 7, 8, or even 5 tasks in some case. In order to respond to that, ECS allows you to configure autoscaling to scale your service horizontally so that it automatically responds to traffic. So what this means is that when you use autoscaling for ECS automatically observes what is the utilization for your compute, and based on the target metric that you specify, ECS scales up or scales down your service to ensure that your application is always right-sized, so that your application is available, but at the same time you're not running more tasks than is absolutely necessary for your application. You can scale your service based on a variety of metrics. It can be ECS metrics, such as the CPU and memory utilization. It can be metrics shipped out of the box by other AWS services, such as ALB or SQS. Or it could be custom application metrics that you generate. Depending upon what is right for your application, you can use the metric of your choice to autoscale your application. All right. With that said, let's move on to the next big bucket: utilization at the cluster level. This is fundamentally a hard problem because a cluster typically has n instances. Let's say a cluster has 10 instances and 10 services running on it. Each service requires a different number of tasks over the course of the day. Now, to make sure that the size of the cluster is sufficient to run all of those 10 services, but also not over-provisioned, is fundamentally a hard problem. To simplify this, in 2019, ECS introduced the notion of what we call capacity providers. When you use capacity providers, ECS automatically looks at not just what your application needs right now, but what is the amount of compute that might be required in the next few minutes. And based upon that, it automatically right-sizes your cluster size. However, this is still a hard problem. In order to ensure availability, you would likely need to have some spare capacity. And it becomes hard. And it's not something that we want our customers to really worry about. So what if you didn't have to think about it at all and instead could just think about running compute? So with Fargate, you could simply do that. You don't need to worry about underlying host instances at all. You're just running tasks on compute that is provided by AWS. So what that means is that you only need to worry about the first two dimensions that we spoke about. First, you want to right-size your tasks so that you're not paying for compute that you aren't utilizing. And second, you need to make sure your service size is correct. As long as those two are fine, you will never be over-reserving and underutilizing capacity that you're paying for. And this is why we've seen customers like Edmunds reduce costs up to 30% by switching to ECS Fargate from EC2 on demand. Quickly moving on to the next big pillar. Choosing the infrastructure choices you make when you run your application on AWS can have pretty strong ramifications on what your AWS bill looks like at the end of the day. There are three key choices that we see to reduce costs. First, what type of hardware you're running. Second, what type of capacity you're running on. And finally, making commitments and reservations which allow you to benefit from commitment-based discounts. So first, AWS Graviton is AWS's own custom silicon that we introduced multiple years back, which AWS Graviton today provides the highest performance in an instance family, 20% lower cost compared to same-sized instances in the same family, and up to 40% higher cost performance. What that means is you can run applications more efficiently at a lower cost. ECS is deeply integrated with Graviton. You can run ECS tasks on Graviton with Fargate. You can run ECS tasks on EC2 with Graviton. You can simply use Graviton instances with an ECS optimized army and use that to run your containers. And ECS fully supports multi-arc images which are needed to run Graviton. And we've seen customers across the board utilize Graviton with ECS for a number of workloads, for everything from microservices to caches to media encoding, analytics, whatnot. Moving on. Spot capacity is spare capacity in AWS data centers, which is made available via Spot. EC2 and Fargate Spot is how you can do more for less. It offers up to 90% on demand, the same host of instance types, the same number of SKU types on Fargate. What this means is you can pay by running your applications which are interruptible. So that's something to keep in mind. When you run Spot capacity, your capacity can be interrupted with a 2-minute notice at any point of time. However, when you're using containers, containers make it much easier to run workloads on Spot, because containers by definition are prone to interruption and are more likely to be cycled around in any case. A quick nuance between EC2 and Fargate Spot. So when you use Fargate Spot, it provides up to 70% discount compared to standard Fargate, whereas EC2 Spot might have higher discounts. And secondly, when you use Fargate Spot, the underlying instance pool that is used for running your tasks is automatically diversified, so the likelihood of seeing an interruption when you run Fargate Spot is automatically lowered. ECS makes it easier to run Spot by handling interruptions automatically. So when you run a long-running application on ECS and a Spot termination notice comes in, ECS automatically reads that interruption notice and gracefully drains any connections to any load-balanced applications that might still be receiving connections. What that means is ECS ensures that all outstanding requests are processed, and once that is done, ECS tells the container that it should shut down. There are a few load balancer configurations here that you need to be careful of when you're running applications with Spot on ECS. However, that is best practice, and doing that allows you to benefit from the steep discounts that Spot can offer. What is more, when you use capacity providers, you can mix on-demand and Spot capacity to improve your availability posture without increasing costs substantially. Capacity providers works with both Fargate and Fargate Spot, as well as EC2 and EC2 Spot. So you can use capacity providers to mix both EC2 and EC2 Spot capacity, as well as Fargate and Fargate Spot capacity. You can't mix EC2 and Fargate capacity on AWS, on ECS today. Finally, I do want to make a brief mention about commitment-based discounts with savings plans. So savings plans provide a flexible discounted pricing model based on commitments that you make to use over an N-year period. Compute saving plans apply to your compute resources across Fargate, EC2, and Lambda, so it automatically applies to any applications that you run on ECS. However, when you use instance saving plans, those are only available for EC2. So that's something you might want to keep in mind. Here's a quick glance of what a Fargate savings, the savings with Fargate savings plan might look like. With a 3-year commitment, you can save up to 52% on-demand costs. With these out of the way, or actually, just taking a moment, we have seen customers like Athena Health reduce their costs up to 73% from running on Lambda by moving their event processing workload to ECS with EC2 Spot. This was our motivation for doing this session in the first place. Architecting your applications to utilize compute efficiently, to operate less, and to use the right set of compute types allows you to unlock significant savings. With that, I'll hand over to Francis. I've worked closely with Francis over the last 2 years, and I've been amazed by how he runs an organization at his scale with such a small team. Over to you, Francis.
Thank you, Vaibhav. I'm excited to be here and talk to you about how CleverTap uses ECS, keeps us agile, and how we leverage AWS ECS to operate infrastructure at scale. Oh, sorry, this is going backwards. All right, so CleverTap, just to give you some background, is an omni-channel customer engagement and user retention platform. Powered by TesseractDB, the world's first purpose-built database for user engagement and retention that delivers incredible performance and lightning-fast data processing and unlimited secure storage capability. This enables us to surface and report unparalleled analytics and insights into user behaviors and trends via cohorts, funnels, trends, flows, pivots, and insights. And then, based on the analytical data and insights, you can engage users across messaging touchpoints, such as push, in-app, text messaging, WhatsApp, app inbox, email, in real time, and offline. Essentially, we enable app owners to retain and grow their user base. And hi, I'm Francis. I'm the VP of Infrastructure and Security at CleverTap. I've been helping keep lights on for 16 years. Been fortunate enough to do it right out of college. The last 8 years I've been at CleverTap. And today I'm going to talk to you about how we do ECS, how a journey that spans essentially of running infrastructure for about 8 years at CleverTap, and a story of how we fell in love with containers and where ECS fits into this whole picture. So from 2012 to 2016, this is the beginning, we used, well, there wasn't a lot of ECS in the first place. So there were MEs. We bootstrapped them for both stateful and stateless workloads. What would happen is then this was a combination of user data coming in and bootstrapping our configuration management system that would then sort of bring in the application runtime environment, bring in the application, start it up. But there was a problem. There were just way too many moving parts in this system. Yeah. Something could go wrong. Every now and then it did. Things such as package repositories being offline during the bootstrap process. And boom, bootstrap failure. Holy shit, we're in the middle of this scale up and bootstrap failures. So there had to be a better way. There just had to be a better way. ME was one of them. I mean, you could burn your ME, including the runtime dependencies and the application. But this meant that for every build, you're making an ME, and that's a lot of MEs in an account. So that's when we came across Docker, a way to package runtime dependencies along with the application without the kernel and the other things that are required to keep the operating system going, interact with the hardware. And so in 2017, we started using ECS with EC2. Sorry, in 2017, we went what I think of as container version 1, where we packaged the application inside a container and deployed it with AWS Code Deploy. No ECS. This worked. But then we realized we were sort of reinventing a container orchestration engine. And that's when we went all in with ECS. But then something interesting happened. So we've been on ECS since 2018 for both stateful and stateless workloads. There's just everything orchestrated with ECS. But then something interesting started to happen. Starting mid-June this year, we kind of made this decision to move to Fargate, to move all of our stateless workloads to Fargate. And I'm going to talk to you about Fargate and why we want to do that. Why would we choose to do that? So, a containerized application is surrounded by its runtime dependencies, that is the root file system. As a team, this is where we want to focus our time and money. There is no business benefit on focusing on patching operating system packages, hardening the operating system. But don't get me wrong here. I'm not saying you shouldn't be doing it. It's super critical, just that there's just no business benefit. Having run security engineering for a while, you have to figure out, how do I balance time and focus on doing these repetitive things as opposed to spending time doing what really takes my business forward. So, what if, just like we don't think about the hypervisor, when was the last time you thought about patching your hypervisor? Just like you don't think about virtualization. What if you could make the operating system go away? And that was our motivation for Fargate. Fargate makes us forget the operating system, so we can just focus on what is key, on the runtime environment, hardening and securing it. All right. The other thing is, like, ECS is great on EC2, but you have to manage these resources inside of the cluster, and resources in the form of EC2 instances, things where your containers run. But the thing is, your ECS container, the resource is decoupled from the containers. So you can find yourself in a state where the service is trying to scale up, but you don't have underlying compute to feed that scale up. In our case, we have custom alarms and Lambda functions all glued together to sort of preempt when a service is going to scale or is likely going to scale, and then feed that capacity in place just before the service is going to scale up so that there is enough resources to run that. But why do it? I mean, you should be able to say, hey, ECS, run this container, and boom, it should come to life. And that's where Fargate comes in, and that's why we made this decision to go all in and we've taken all of our stateless compute and moved it off to Fargate. This was like a 3-month exercise, and I'm going to tell you things that we learned, not just from the Fargate migration, but things from just operating ECS over the last 4 years. You would expect sort of cluster events, all these things that are going on inside of a cluster, things such as containers starting up, containers scaling out, containers registering with a load balancer, containers being terminated, containers restarting in a restart loop. And you expect to see them in the CloudTrail so you can sort of put up monitoring, alerts, alarms, that kind of stuff. But it doesn't. That's not how it is. And then it kind of struck us, right? Just like you don't see queries from an RDS database inside of a RDS database in the CloudTrail, or S3 data events get and put in the CloudTrail. These are events happening inside of a service, so they don't show up in the CloudTrail. I wish somebody told me this up front. The good news is that you can send it to EventBridge, and then from EventBridge, you can take it to whatever monitoring system you got and do what you want and what you expect to do with it if they showed up in CloudTrail. The other thing is tasks can't be protected. So you can essentially take an EC2, you can take an EC2 instance out of a load balancer to sort of observe the application's behavior without exposure to traffic. If you attempt to do that with ECS, both on EC2 as well as Fargate, the task is destroyed. There's like some kernel capabilities that don't work on Fargate. For most use cases, you probably wouldn't encounter it. But if you do, I want to tell you up front, there are these nuances, and you should go check them out. So I told you, it take like 3 months to move from EC2 ECS to ECS Fargate. And that's weird, right? These are containers. They should just move from one place to another. And why does it take so long? Turns out, the application used instance IAM credentials when it started making these calls to other AWS services. Now, when you move the application over to Fargate, you no longer control that ECS, the underlying host, and so you cannot attach an IAM role to it. And so Fargate forces you to sort of use the task IAM role. And now suddenly you have to go find every place there is an AWS client in your application and change it to a default credentials provider chain. I wish somebody told me this up front. I wish this is documented, and I wish the AWS APIs said, warning, do not use task IAM role or instance IAM role. Instead, use the default credentials chain, because that's an interesting one. That one attempts to use credentials from what is available. So if the task role is available, it tries to use those credentials. And then if it isn't, it'll fall back to your instance. And this allows your application to run off ECS, Fargate, as well as EC2. And this is what set us back, like a simple thing that had to move from EC2 to Fargate. It set us back by 3 months. You can sort of orchestrate stateful workloads with ECS and EC2, with the state being persisted on an EBS volume, with some hacks that basically pin a service to a specific place where you want it to be. But on Fargate, you can only do persistence with EFS. There's just no support to be able to do persistence with EBS. And so these guys move these containers over from EC2 to Fargate. And they spend a lot of time trying to figure out what's wrong. Why isn't it working the way it should? And turns out, ECS exec is the answer. You can go drop in, though you don't control the underlying EC2 instance, to see what's going on, just like you would if it was EC2. You could SSH, SSM, and go see Docker tail containers to see what's going on. So ECS exec, definitely a win, but needs to be enabled upfront. And when you're running stateful workloads on ECS, it turns out that if you want to change the instance type of the underlying container, you have to go destroy, terminate it, get rid of it, and then bring it back to life so that ECS can then register it. But if you just sort of update it in place, shut it down, bring it back up as a different instance type, up or down, then ECS is bluntly going to refuse to use it. And then having run sort of containers for the last 4 years, this independent of ECS, here's my takeaways. In the beginning, we almost like built these custom containers because we had to adapt like upstream containers for our use case. Over time, containers became mainstream. And we realized that we're doing it wrong. There is almost always a way to make the container behave and act and adapt to your environment from the outside or from these sidecar containers that contain configuration files that can be mounted into an OEM container, thereby letting you not have to worry about building these containers and build pipelines and things like that. The other thing is ECS, like I told you, we spend a lot of time going in and figuring out why is this container not doing things? Like is it really reading my values? It's understand all these environment variables or not? And turns out exec is pretty cool. It's also cool if the service is breaking and you're in the middle of trying to fix it. But the thing here is that it needs to be enabled upfront. It's not something you can turn on the fly, not some checkbox you can run at runtime. So you have to sort of just say upfront in a task definition that you're kind of enabling ECS exec. And then there's the sidecar deployment model. So instead of like packing your container into one large monolith, for example, imagine an application and logging agent along with it, right? Your application runs, and there is a logging agent that ships all of your logs to some central system so that it's there for analysis and things like that. Instead of putting these two together into one monolith sort of container, stick by the one application per container deployment model. And so in our example, that works out to 2 containers in a task, the application itself and the log monitoring agent. And then you can do mount points that can be shared between the containers, thereby enabling the log forwarding agent to read the application logs and ship it to your central monitoring system. And then, having run ECS for like the last for the 4 years, here's what we have, or I have to tell you as takeaways. It can be frustrating to debug why a container is behaving in a specific way if it's just in a random restart loop. There's no way to tell what's going on. So you can use remote logging drivers that take your standard out and they ship it to a remote logging system. Suddenly, you have visibility into what the standard out of your container is. I mean, you could do this on EC2, but you can't do this you can't go Docker log on Fargate. So specifically, when going to Fargate, this is absolutely critical to save so much time. Then there's all these events going on, depending on how large your deployment is, how many clusters you have, how many tasks, services. There's just crazy stuff going on all the time inside the stuff. Makes sense if you're doing ECS, EC2, to ship your ECS agent logs over to a central monitoring system so that when something behaves weirdly, you at least have something to look at, a 3,000 feet view into peeking in to see what's going on. And irrespective of ECS, EC2, or ECS Fargate, the cluster events themselves, shipping them off to a central monitoring system, enables you to look at like a 3,000 feet view into what's going on. And then this is my most favorite recommendation. Clusters are cheap. They are zero maintenance, and they cost zero. In our case, we just take we literally deploy it like one microservice per cluster. It's very simple. When you have to explain this to new people who you just hired, people who are just starting out, people getting into your team, and developers, it's simple. It runs one cluster in one service. Are you on? That's all I got.
Yeah. Before we close, I did want to take a minute to go through some of the key takeaways from the session so far. So the first, Amazon ECS provides fully managed container orchestration, built-in capabilities, is fully integrated with AWS, so you don't have to think about things that don't create value for your business. With Fargate, you get free instance management, free capacity management, so you don't need to think about maintaining sufficient capacity or being over-provisioned. All of that is taken care of. Patching is taken care of. You should use service scaling and task right-sizing to make sure that you're efficiently utilizing your compute at all times. You should, if your application allows it, try using AWS Graviton. We've seen customers see up to 40% reduced costs simply by making that jump, especially for applications such as Java applications, Node.js applications, things like that. It's fairly easy to make that jump. Next, you should consider mixing some on-demand and spot capacity to reduce your overall infrastructure cost. As we saw earlier, there's fairly deep discounts to running with spot capacity, and maintaining a healthy balance between on-demand and spot capacity allows you to run your applications in a resilient, reliable manner without adding a lot of cost, or in some cases, reducing your cost substantially as well. And finally, and probably the easiest thing to do, in case if you have sufficient, if you know that you're going to be using sufficient amount of compute over the next 10 years, you should strongly consider enrolling in a savings plan. The discounts that it provides meaningfully add up over time. I know for some more seasoned users in the audience, they might question some of the statements that are made here. So that's why I will add the caveat that for some of these statements, it depends. However, based on my experience talking to hundreds of customers and based on what we've seen internally, most of these recommendations hold for most customers, even some of our largest ones. So if you were to take a few takeaways today, I would say try to follow some of these. This can mean a fairly material reduction in your overall cost of operations. Here's a small set of resources which you can check out. All of this will be included in the slide deck, which will be uploaded to the session portal, so you don't have to worry about taking pictures. But yeah, that's about it. It seems like we do have time left for Q&A, so if there's any questions that folks want to ask, we can use the next 9 minutes. Please go ahead.